Hello and Namaste. In continuation with the Z transform, we'll be starting with the problems of based on the standard functions, and we'll be using here the Z transform of the different standard functions as well as some other algebra to prove or to find out the Z transform of this particular problems. Find the Z transform of a to the power n cos hyperbolic a n, and second is 2 to the power n sin hyperbolic 3n. Now if you'll observe here, Z transform of a to the power n cos hyperbolic a n is nothing but this. So cos hyperbolic theta, we have taken the formula for a to the power n, e to the power a, so a to the power a n as it is, whereas cos hyperbolic theta we have taken e to the power a n plus e to the power minus a n by 2. Again, this can be written as, or this by the linearity property we can have it as 1 by 2 because of the constant. Z transform of a into e to the power a to the power n. Actually it has to be like this round bracket to the power n. Similarly plus z a into e to the power a to the power n. Now we have got this particular standard formula, that is Z transform of a to the power n is equal to z upon z minus a. Now in the current this particular example here, we have got this small a is equals to a into e to the power a. Similarly here it is nothing but a into, so this a is nothing but a into e to the power minus of a. So this particular thing will be getting replaced over here in this case, and therefore this is 1 by 2 z upon z minus a into e to the power a plus z upon z minus a into e to the power minus of a. Moving ahead and taking the LCM cross multiplication, just adjusting the terms, we are going to reach to this particular thing. If you'll observe here, we have just clubbed this e to the power a plus e to the power minus a and e to the power a plus e to the power minus a, which we have done in the previous session as well, and we have written this as nothing but cos hyperbolic a, and this 1 by 2 we have taken care of this. So that means dividing and multiplying by 2 over here, we'll be getting this particular thing over here, that is cos hyperbolic a, and this is nothing but the final answer is Z transform of a to the power n cos hyperbolic a n is equals to z into z minus a cos hyperbolic a upon z square minus 2a cos hyperbolic a into z plus a square. Now moving ahead with 2 to the power n sin hyperbolic 3n is nothing but again the same sin hyperbolic 3n with the, if you put the formula for that, that is nothing but this, again moving the same way what we have done it in the previous case. Then the same formula we are going to use it here. That's the reason this is the two combined. I have combined these two questions because the methodology is almost same. And moving ahead, we will be getting 2z sin hyperbolic 3 upon z square minus 4z cos hyperbolic 3 plus 4. Pause the video after this particular thing and try to get this particular answer on your own. Second is find the Z transform of f of n, that is a n squared plus b n plus c, and f of n is equals to 1 by 2 n plus 1 into n plus 2. Now if you'll observe here, this particular function, if you are taking the Z transform of this function f of n, we will be using here the linearity property. So a is coming out Z transform of n square plus b into Z transform of n plus c into Z transform of 1. Now we know that this is the one property which we have already seen in detail, that is the Z transform of n to the power k is equals to minus z into d upon dz of Z transform of n to the power k minus 1. This is also a recurrence relation, we can check it here, and therefore because of this we can easily have, we know one thing is that this is Z transform of 1 which is equals to z upon z minus 1. Then moving with this recurrence formula as we have already seen, that is Z transform of n is nothing but z upon z minus 1 the whole square. Please go in and reach to that I button for this particular session which we have already taken it. And therefore Z transform of n square you can have it at z into z plus 1 upon z minus 1 the whole cube. We will be applying this formula over here and we'll be taking the Z transform of n square, Z transform of n and Z transform of 1 from this 1, 2, 3, and we'll be getting this. Again from here, if you are taking z minus 1 the bracket cube in the denominator out as well as the z from the numerator out, we'll be having in the square bracket as a into z plus 1 plus b into, because we have got it here 2 and we have taken the cube out, so we have to multiply b with z minus 1 plus c, we have got just the denominator, we have just got z minus 1 and but we have taken to the power 3, so we have to multiply c with z minus 1 the square. Again, opening the brackets and adjusting the terms, we are just pause the video here, try to get this as the final answer for the Z transform. I'm not spending the time here in the minute calculations which you can easily take it up. My target is for this particular sessions are to make you understand and make you realize how to use the different formulae or how to use the standard formulae and reach to the Z transform of different functions. Now moving ahead with the second, so we have got the first, this one. Moving ahead with the second, this is nothing but 1 upon 1 by 2 into n plus 1 into n plus 2. Multiplying these two brackets will be having 1 by 2 into n square plus 3n plus 2. Again, we have reached to the same type of questions over here. So I'll be just moving ahead fast, and this will be getting this function, the value of this particular function as z cube upon z minus 1 the whole cube. As we have already, you can see it here, the value of this a is equals to 1, b is equals to 3, and c is equals to 2. If we'll take these values of a, b, c in this particular formula, get it, you will reach to the same what we have got it here. But yes, I've tried to show you the steps which we have already done it in this case, and we can reach to this particular question in this way. Yeah, and this is the first part only for the problems. Please do connect it and stay tuned for the upcoming sessions of the Z transform. Z transform is a little bit of interesting topic, but provided you should understand all the theory or all the properties and the standard function, the Z transform of the standard function in detail. Stay tuned, stay connected. Thank you. Happy learning.